All right, before we get to the main part of the lab, I just wanted to go over this new equipment, the Atwood Apparatus. It is new, and want to make sure that you guys are successful in using it. This episode brought to you by Coca-Cola. No, I'm just kidding. All right, so this is a new instrument, and I never really got around to using this much when I was teaching, but it does have some very good uses for force demonstrations. One thing that you want to check, because I just found this out trying to create another segment, is make sure that these guys spin pretty freely. I was trying to set this up with one and the friction was too high. When I set up the pulleys, it did not even move at all, even though they're different weights. So this one, much better. So check your stuff prior to doing this lab and let me know. On the back, the way that you know which way it's going to be put on, you'll have this little indent there. And so if you go up to the top screw, you'll see that'll fit nicely with your stand, and it'll keep it, once you're in there, keep it from rotating. In the same kit that this came in, you'll have other accessories like the backing to this. So we'll go ahead and get him on. Ooh, not mess up on camera. There we are. Okay, for the first part of the lab, you won't need it, but just I'll show you guys now. Your normal CPO timers work with this. They actually measure these little black lines and how fast they're rotating. You want to have your plunger all the way pulled out, and that's going to face the back, and it should slide right in where that metal bracket is at and push down until it doesn't push down anymore. You'll see that it's right there, and then the laser light is going to be right where those black lines are. So it should see it kind of like that frequency as it goes through, and that's going to calculate your rotational speed. Then you have your weights. The instructions tell you that mass 1 will be 10 solid metal weights, and the other one is going to be mainly metal and then some plastic on there. So we'll go ahead and set this guy up. And I believe you lift up mass 1, which doesn't have any plastic, and when you let go, you should see that it falls. It does give instructions that at the bottom you should probably put down a foam plate or some paper or something, so that way you're not getting dents down at the bottom. That might be a smart thing to do, but that one's not moving too fast. It is going right directly towards the balance, and so that might be something you cover up. Okay, so that's kind of the general setup. All the accessories were in the kit. You just screw in a bolt onto that plastic piece on the bottom, and then you can put your washers on, and then you can clip on your registering. So that makes it pretty easy to take off, change your weights, and then clip back on with good finger dexterity. There you are. All right. Okay, so when you actually get to the lab part of this, you should already have your apparatus set up. I've just gone ahead and included, let me show you. I've just included the sensor already on there. For the first part of the lab, they won't use that. They're just looking at it qualitatively, observing the masses, answering some questions. But since the next part does require to have the timer set up, I went ahead and just already included that. Make sure that the light is green or red when you hook this up. It just depends on whether the laser is being blocked or not. And then we need to set up our data collector. So let's jump over to that into data collection mode. So let's get rid of that brightness. There we are. So under data collection, come on, focus. Let me get this not so blurry for you guys. There you go. All right, the default's going to be a little bit different, but make sure your samples are set to 500. Your rate is set to 5. Over here, I believe this defaults to PGA, so change it to SPA. That should allow you to do your speed in centimeters per second. Make sure that these two are none. I think when you hook it up, it tries to do a frequency, but switch this guy to none and that gets rid of everything. So I'm going to go ahead and hit go, and that's going to give me the countdown. I'll set up the experiment, let it go. Your students will have more hands than I do right now, so they can have it all set up, ready to go. All right, to stop this, quickly hold that for a second. you'll see that stop the experiment. There is no stop button. So you're going to tell your students that you click it for 1 second. No longer, you start to power down. Let's actually look at what that graph looks like. Okay, so I do have a speed here. There, okay. I don't know what I was looking at before, but here is my speed. Let me zoom out and see what we got. So I think this is what I want. This initial part was probably me setting it up because I was not quite ready. So your student's data is probably going to start here, and then they should see the speed increasing. So it's at 0, you can see this is my 0, and then my speed slowly increases as it falls. And there you've got your velocity over there. You can actually go and find different data points. You can see the crosshairs changing. So I can look at my velocity at any given point along that line. So once they've got that, they'll be able to fill in some data for some different masses. Just follow the instructions on all that, and then it's just simple questions, graphing. You figure out what is appropriate for your grade level and your students, whether you're honors or not, and that is 3.2 using the Atwood apparatus.